Let us look at an example of linear programming using graphical method for a minimization objective. The R&D department of a metal manufacturing company has two melts of copper nickel alloy to make up a new alloy. The compositions of the alloys are given to us. So for melt 1, two parts are copper and one part is nickel, while for melt 2, one part is copper and one part is nickel. So basically, in case of melt 1, if we divide the melt into three parts, two parts are copper and one part is nickel. And for melt 2, if we divide in two parts, one part is copper and one part is nickel. Now to make up the new alloy, at least 10 kgs of copper and 6 kgs of nickel is needed. Melt 1 costs rupees 25 per kg, while melt 2 costs rupees 30 per kg. How much quantity of each melt should be used in order to minimize the cost? Now we have already seen how to formulate the linear programming model for this problem in another video of linear programming model formulation. So let us note down the linear programming model that we had arrived at in the other video and see how we can solve that using graphical method. So the decision variables the first decision variable was x is the quantity of melt 1 to be used, and y was the quantity of melt 2 to be used. The objective function was c is equal to 25x plus 30y, where we have to minimize c. Next is the constraints. So the first constraint is 4x plus 3y is greater than or equal to 60, and the second constraint is 2x plus 3y is greater than or equal to 36. So let us look at how to solve this using the graphical method. So here first we'll plot the graph for the two inequalities representing the constraints. The common area represented by these two inequalities would represent the feasible solution region, and then we will try to find out the optimal solution for the objective function. Now to plot the graph for these two inequalities, let us assume that the horizontal axis, which is the x-axis, represents the quantity of melt 1, and the y-axis, which is the vertical axis, represents the quantity of melt 2. Now since one of the constraints for solving linear programming models is that the decision variables should be greater than or equal to 0, we are plotting this graph on the first quadrant where the values of x and y are either 0 or positive. Now to plot the constraints, we'll drop the inequality sign and we'll convert these equations into a straight line equations, that is 4x plus 3y is equal to 60 and 2x plus 3y is equal to 36. Now to plot these straight lines, we need at least 2 points through which these lines would pass. So the easiest way would be to find these 2 points on the x and y axis where these lines intersect the x and y axis. This can be found by putting the value of x and y alternatively and finding the x and y intercept. So let us find the x and y intercept for these lines. So the first equation becomes 4x plus 3y is equal to 60. So here let's first put x is equal to 0. So then we get 3y is equal to 60, or y is equal to 60 by 3 is equal to 20. Next, if we put y as 0, we get 4x is equal to 60. X is equal to 60 divided by 4, which is equal to, so dividing 60 by 4, 4 ones are 4, 2 carry over, 5s are 20. So we get 15. So for this equation, the y-intercept is 20 and the x-intercept is 15. Now the next equation is 2x plus 3y is equal to 36. So in this, let's first put x is equal to 0. So we get 3y is equal to 36. Y is equal to 36 by 3. This is equal to 12. Next, let's put y is equal to 0. So we get 2x is equal to 36, or x is equal to 36 by 2, which is equal to 18. So for this equation, the y-intercept is 12 and the x-intercept is 18. Now with this information, we can plot these two lines. So let us do that. Now as you can see in this graph, now based on the x and y intercept for the constraints that we had found earlier, I have decided the scale for this graph. Now the first equation, 4x plus 3y is equal to 60, has a y-intercept of 20 and x-intercept of 15. So let us draw this line. Now this line represents 4x plus 3y is equal to 60. Now since the inequality that we have is 4x plus 3y is greater than or equal to 60, so all the points on this line represents 4x plus 3y is equal to 60, while all the points above this line, that is in this direction, would represent 4x plus 3y is greater than 60. We can easily validate this by substituting x and y with any point or with any coordinates of any point on this side of the line. So suppose we take the coordinates 0, 24, which is for this point here. So we'll take 0, 24. So 4 multiplied by 0 is 0, plus 3 multiplied by 24. So this is equal to 3 4s are 12, 3 2s are 6, 72. Now this is definitely greater than 60. So this point does meet the criteria 4x plus 3y is greater than or equal to 60. Now the next equation is 2x plus 3y is equal to 36, and it has a y-intercept of 12 and x-intercept of 18. So let us plot this line. So this line here represents 2x plus 3y is equal to 36. So all the points on this line will represent 2x plus 3y is equal to 36. And for the inequality 2x plus 3y is greater than or equal to 36, all the points on this side would represent that. We can again verify this. Let's take this point here, which is 12 and 0. So 2 multiplied by 12 plus 0, that is 3 multiplied by 0 is 0. So 2 multiplied by 12 is 24. Now 24 is less than 36. So this point does not meet the criteria 2x plus 3y is greater than or equal to 36. And if we take a point on this side of the line, you'll see that it meets this constraint of 2x plus 3y is greater than or equal to 36. Now after plotting both the constraints, let us find out the feasible solution region. So as you can note, this region here above these two lines is what is the feasible solution region. So the area that is on this side would represent the feasible solution region. So here we can note down the edges of this region as A, that is this point here, then B, which is this point here, and C, which is this point here. Now after finding the feasible solution region, the next step would be to identify the optimal solution. To do this, we have two methods. The first method is to draw a series of objective function lines. So the objective function that we have is c is equal to 25x plus 30y. So we can convert this equation into the standard line equation, that is y is equal to mx plus c, and once we know m, that becomes the slope. So using that slope, we can draw a series of parallel lines to each other. On any particular line, the different combinations of x and y will give the same cost. Now we'll start drawing these series of lines from the point as close to the origin, and as we move upwards away from the origin, the nearest line to the origin touching the feasible solution region will represent the minimum cost. Once we identify that point, we then need to find the coordinates of the point. So either we can find the coordinates of the point from the graph, or we can solve the two equations at the intersection of which this point lies. When we solve these two equations, the value of x and y will be the coordinates of this point, and the value of x will represent the quantity of melt 1, and the value of y will represent the quantity of melt 2. Now note that in this case, since this is a minimization problem, the objective function line which is nearest to the origin and touching the feasible solution region will give us the optimal solution. Whereas if it was a maximization example, the farthest line from the origin which touches the feasible solution region gives the optimal solution. Now the second method to identify the optimal solution says that the optimal solution lies on one of the edges of the feasible solution region. Now again, since this is a minimization problem, these edges would be the ones which are towards or nearer to the origin. So in this case we have three edges, that is A, B and C. So if we can identify the coordinates of these points, then we can use these coordinates to solve the equation C is equal to 25x plus 30y to find the value of C. The coordinate which gives the minimum value of C would be the optimal solution. So here the coordinates of A and C can be determined easily. So the coordinates of A are 0 and 20. So the x coordinate is 0 and the y coordinate is 20. For point B, we can find the coordinates by solving the two equations for these two lines at the intersection of which this point B lies. For point C, the coordinates are 18 and 0. So let us find out the coordinates of B, and then we'll use these three coordinates to find out the optimal solution. So the coordinates of point A are 0 and 20. For point B, we need to solve the two equations 4x plus 3y is equal to 60 and 2x plus 3y is equal to 36. So if we subtract the second equation from the first equation, we get 2x is equal to 60 minus 36 is 24, or x is equal to 12. Now if we substitute x is equal to 12 in any one of these equations, so let's do the second one for ease of calculation. 2 multiplied by 12 plus 3y is equal to 36. Or 24 plus 3y is equal to 36. 3y is equal to 36 minus 24 is 12. Y is equal to 12 divided by 3 is 4. So the coordinates of point B are 12 and 4, and the coordinates of point C are 18 and 0. Now we know that one of these three points will provide us the optimal solution. So let us solve the objective function for the value of C by substituting the x and y values for each of these 3 points. So our objective function is C is equal to 25x plus 30y. So for point A, which is 0, 20, C is equal to 25 multiplied by 0 plus 30 multiplied by 20. This is equal to 30 multiplied by 20 is 600. So this is the cost at point A. Now the coordinates of point B are 12 and 4. So C is equal to 25 multiplied by 12 plus 30 multiplied by 4. This is equal to 300 plus 4 3s are 12, so 120. This is equal to 420. Now the coordinates of point C are 18 and 0. So C is equal to 25 multiplied by 18 plus 30 multiplied by 0. This is equal to 450. So if we compare the cost at the points A, B and C, the cost at point B is minimum. So B is the point which can provide us the optimal solution or the least cost. So the value of X and Y should be 12 and 4. So melt 1, the quantity should be 12, and melt 2, the quantity should be 4. Now this is in kgs. So don't forget to put the unit of measure because that makes a huge difference.